We did specific heat capacity. Now we are doing only heat capacity. There is slight difference between specific heat capacity and heat capacity. Heat capacity is also called as thermal capacity. Amount of heat required by unit mass of substance to rise or fall its temperature by 1 degree Celsius or 1 Kelvin was called specific heat capacity. In that we had taken unit mass of substance. Here only the change total mass of substance. That means total body. S was specific heat capacity, which is heat for 1 kg, then for 2 kg 2s, 3 kg 3s, mkg ms. So ms becomes our heat capacity for whole body or called as thermal capacity. The amount of heat required to raise or lower the temperature of whole body by 1 degree Celsius or 1 Kelvin is called as heat capacity or thermal capacity. The amount of heat required to raise or lower the temperature of whole body by 1 degree Celsius or 1 Kelvin is called as heat capacity or thermal capacity. Okay, please write this, then formula will write. The amount of heat required to raise or lower the temperature of whole body by 1 degree Celsius or 1 Kelvin is called as heat capacity or thermal capacity. Amount of heat required to raise or lower the temperature of whole body by 1 degree Celsius or 1 Kelvin is called as heat capacity or thermal capacity. Yes, can I clear this?
Yes, sir.
Yes, sir.
Therefore, heat capacity equals to mass into specific heat. Therefore, Q equals to Ms. Its SI unit is Joule per degree Celsius. Copy this much.
Done, sir.
See, I'm just creating one formula. Sometimes this is also given for heat capacity. If H is heat capacity, since Q equals to mass into specific heat into change in temperature. So Q upon change in temperature is Ms. Therefore, heat capacity is M is Q upon delta T. So sometimes in entrance they will give you heat and they will give you change in temperature, not the mass. Then from that also we can write total heat upon total temperature is also called heat capacity. So just write as a note. If H is heat capacity, then total heat is Q equal to Ms delta theta. In that case, heat capacity will become Q upon delta theta. Q upon delta theta is Ms, therefore H equals to Q upon delta theta. Write that much. Done?
Yes, sir.
Write one numerical. Find thermal capacity for a copper block. Find thermal capacity for a copper block of mass 0.2 kg if specific heat capacity of copper is 290 joule per kg degree Celsius. Find the heat capacity for copper, that is Q, which is thermal heat capacity, mass 0.2 kg and specific heat S is 290 joule per kg degree Celsius. So since heat capacity is Q equals to mass into specific heat, that is 0.2 into 290, 29 into 2 will become 58. Unit is joule per degree Celsius. Heat capacity unit joule per Celsius. Complete. Is done?
Yes, sir.
Have you heard about calorimetry? The thermometry is branch of physics which deals with measurement of temperature. So calorimetry is also branch of physics which deals with measurement of quantity of heat. Temperature then thermometry, quantity of heat then calorimetry. So somebody says, what is calorimetry? The measurement of quantity of heat is called as calorimetry. The measurement of temperature is called thermometry. Measurement of quantity of heat is called as calorimetry. So first write only what is meaning of calorimetry. The measurement of quantity of heat is called as calorimetry. Then we'll see what is calorimeter, how it can be used to measure the heat.
Done, sir.
The measurement of quantity of heat is called as calorimetry. Explain construction and working of calorimeter. It consists of a cylindrical vessel usually made up of copper. It consists of cylindrical vessel usually made up of copper filled up to two-thirds of its capacity by water. It is supported by pointed wooden. It is mounted on pointed wooden support to prevent the heat lost by conduction. It is kept in a wooden box to prevent the heat lost by radiation. It is covered with wooden lid. Lid means dhakkan. Wooden lid provided with two openings. One for thermometer to record the temperature, other for stirrer to make the temperature uniformly distributed. The wool or insulator is filled in the space between calorimeter and wooden box. So this is wooden box in which copper calorimeter is placed. Or we can say copper vessel is placed. Copper vessel. wooden lid. This is stirrer, thermometer. Here inside it is insulator, filled with insulator to prevent the heat loss, and filled with water. Diagram clear?
Yes, sir.
It consists of copper vessel filled with water up to two-thirds of its capacity. It is mounted on pointed wooden support to prevent the heat loss by conduction, covered with wooden lid, provided with kept inside the wooden box, covered with wooden lid, provided with two openings, one for thermometer, other for stirrer. The space between the copper vessel and the wooden box is filled with insulator. Just draw the diagram. Completed diagram part.
Yes, sir.
Right. Everybody has done. Can I remove the diagram?
Yes.
Yes, sir.
Now, it consists of copper vessel filled up to two-thirds of its capacity with water. It consists of copper vessel filled two-thirds of its capacity with water. It is mounted on pointed wooden support. So if it is kept directly on the surface, then larger area will take more heat to the surrounding. So you have electric iron at home.
Yes, sir.
Sometimes we check whether it is heated or not by putting entire electric iron on our face. एक छोटा सा टिप ऑफ अपना फिंगर से चेक करते गरम हुआ क्या नहीं. तो टिप ऑफ फिंगर से चेक करेंगे तो टिप ऑफ फिंगर का एरिया बहुत कम रहता है जिसको हीट मिलेगा. So you will not experience more heat. That's why it is supported on pointed wooden support. Wood है तो heat ले conductor नहीं है, plus pointed है तो कम surface area is losing the heat. That means idea is we have to prevent the heat lost. So it is mounted on pointed wooden support to prevent the heat lost. To prevent the heat lost by conduction. What is conduction? I will explain you later in heat transfer. It is kept in wooden box and covered with wooden lid, provided with two openings, one for stirrer and other for thermometer. The space between wooden box and copper vessel is filled with insulator. The space between wooden box and copper vessel is filled with insulator. Done? Should I clear this?
Done, sir.
No, sir.
Yes, Simon, completed.
Sir, just a minute. Done, sir.
This was its construction, now working. It is used to determine specific heat capacity of a body. It is used to determine specific heat capacity of a body by the principle of conservation of energy. By the principle of conservation of energy is heat can neither be created nor be destroyed, but it can be transferred from one body to another. So it is used to determine the specific heat of a body by principle of conservation of energy. It uses method of mixture. Now just write this much, then I'm writing, I will explain you the use. It is used to determine specific heat of a body by principle of conservation of energy. It uses method of mixture. So sometimes they can ask in MCQ, which technique is used to find specific heat? The technique is called method of mixture. Chalo, can I clear this? Now we'll see calculation.
Yes, sir.
Okay. Consider a hot solid body of mass m1 at temperature T1 to be dropped in water of mass m2 at temperature T2. Let m3 be mass of calorimeter and stirrer. Who will lose the heat?
Solid.
Hot solid body which is at higher temperature will lose the heat, which will be gained by water and calorimeter and stirrer.
Calorimeter still.
Yes. So let M3 be the mass of calorimeter and stirrer. The heat is lost by water and gained by calorimeter and stirrer. Let T be the
Heat is lost by body.
heat is lost by body and gained by water and calorimeter and stirrer. Let T be the final temperature of mixture. Of mixture means all the three: calorimeter, water, stirrer, all comes at temperature T. Then there is neither loss nor gain. So please write this much also. Consider hot solid body of mass m1 at temperature T1 to be dropped in water of mass m2 at temperature T2, m3 be the mass of calorimeter and stirrer. The heat is lost by body and gained by water and calorimeter and stirrer. Let T be the final temperature of the mixture. Yes, can I clear?
Yes, sir.
Others have done?
Yes, sir.
Okay. Let S1, comma S2, comma S3 be specific heats, of hot body, comma water, comma calorimeter and its content. And its content is that stirrer, respectively. Therefore, heat lost by water Q1 equals to mass into specific heat into change in temperature. What was temperature of solid body? T1? T1 we have taken a T1
Yes, sir.
and final temperature is T. So its temperature was large, it loses heat and becomes T. Heat lost by body Q1 is its mass M1, specific heat S1 and change in temperature. Now heat gained by water in bracket Q2 is mass of water, specific heat of water, change in temperature of water. Water was initially at lower temperature, final is more. So final minus T2 initial temperature. Heat gained by calorimeter and its content Q3 will be its mass M3, specific heat S3 into change in temperature T minus T3. In fact, calorimeter and water will be at same temperature. So we can write this as T2 because content is same as that liquid inside. So it will be also remaining as T2 because here you can write T1 is same as T2 is same as T3. Like if I take a glass of water, then glass ka temperature, water ka temperature both is same. So just copy now this also. Now we have to just use conservation of energy concept.
That's sir.
Everybody is done? Can I clear full?
Yes, sir.
Yes, sir.
Assuming that there is no heat lost to the surroundings by principle of conservation of energy, heat lost equals to heat gain. Therefore, mass m1, specific heat s1, change in temperature T minus T1 of the hot solid is mass of water, specific heat of water, change in temperature T2 minus T minus T2. This is final temperature is less, so T1 minus T. Here final temperature is more, therefore initially it was at temperature of T2. So T minus T2 plus mass of calorimeter and its content M2, M3, S3. Its final temperature is T. Initial was less, so T minus T2, S3. Therefore, M1 S1 T1 minus T equals to T minus T2. We can take common here, M2 S2 plus M3 S3. Therefore, S1 equals to T minus T2 into M2 S2 plus M3 S3 upon mass is M1 and temperature T1 minus T. T minus T2 M2 S2 plus M3 S3 upon M1 T1 minus T2. Using above formula, specific heat of the body can be determined. We will never by heart this last formula. Always I will take individual body, water, container and equate, because this is chances are there we make mistake. So just copy this. In theory, if it comes, you have to write this much for 3 marks. Assuming that there is no heat loss to the surrounding by principle of conservation of energy, heat lost by solid is heat gained by water and calorimeter and its content.
So temperature gained by the water and calorimeter is same.
Yeah, because water का जो भी temperature है वही उसका body
वही
करेगा.
उसका what करेगा.
Done, sir.
Shall I clear poll again?
Yes.
One numerical based on this calorimetry. A sphere of aluminium of 0.06 kg, and sphere of aluminium 0.06 kg is placed for sufficient time in a vessel containing boiling water so that the sphere is at 100 degrees Celsius. So that sphere is at 100 degrees Celsius. It is then immediately transferred to 0.12 kg copper calorimeter containing 0.30 kg of water at 25 degrees Celsius. The temperature of water rises and attains a steady state at 28 degrees Celsius. Calculate the specific heat capacity of aluminium. Calculate the specific heat capacity of aluminium in bracket specific heat capacity of water equals to 4.18 into 10 raised to 3 joules per kg Kelvin, and specific heat capacity of copper equals to 0.387 into 10 raised to 3 joule per kg Kelvin. Such a lengthy question. Completed? Again, question.
Done, sir.
Okay, now one by one I'm reading and writing the notation as 1, 2, 3. A sphere. Sphere means that solid body. If I take that as 1, so mass of that sphere is 0.06 kg. It's placed for sufficient time in boiling water so that its temperature T1 is 100 degrees Celsius. It is then dropped in the calorimeter whose mass M2 is 0.12 kg, containing water of 0.30 kg at temperature T2 of 25 degrees Celsius till the temperature finally becomes 28 degrees Celsius. Calculate specific heat capacity of aluminium S1. Copper we have taken 2, water we have taken 3. So copper specific heat is 0.387 into 10 raised to 3 joule per kg Kelvin, and that of water 4.18 into 10 raised to 3 joule per kg Kelvin. By principle of calorimetry, heat lost is equals to heat gained. So mass of sphere, specific heat of sphere, change in temperature of sphere is T1 minus T, is mass of copper, specific heat of copper, change in temperature of copper, which is T minus T2, plus mass of water, specific heat of water, M3S3 into T minus T2. So can I say therefore T minus T2, I am taking common, into M2S2 plus M3S3. Therefore specific heat will become T minus T2 M2S2 plus M3S3 upon M1 into T1 minus T. Please copy till this. Now we have to just put the values.
Answer.
Now just putting those given values and solving will get required answer. Can I clear full?
Yes.
Yes, sir.
Okay, 1 minute. Now I can clear? Hello?
Yes, sir.
S1 equals to T minus T2. What is T? Is it 28?
28,
28. And T2, initial temperature of water and
25,
25.
then mass of copper 0.12 into its specific heat 0.387 into 10 raised to 3 plus water 0.30 into 4.18 into 10 raised to 3 upon mass of that sphere 0.06 into its change in temperature will be 100 minus 28. So S1 equals to 3. 10 raised to 3, 10 raised to 3 you can bring common. So this is 0.12 into 387, which will become 12 into 7, 84, carry 4. 12 into 8, 96 into 4 plus 400, 0, carry 10. 12 threes are 36 and 10, 46. After 1, 2, 3, 4, 5 digit, you have to put decimal. So we can remove the decimal and write 10 raised to minus 5 into 10 raised to 3. This will also do. Plus 3 into 8, 24. 3 into 1, 3 and 2, 5. 3 fours are 12 and this 0. Then after 1, 2, 3, 4 digit decimal. Or I can say 10 raised to minus 4. I have removed the decimal. Into 10 raised to 3 upon 6 into 10 raised to minus 2 into 100 minus 28 will become 72. 3 into 2 is 6. Therefore, S1 equals to. Both will make it like term so that we can add. So 4, 6, 0, 2, 10 raised to minus 5 and plus 3, that will become minus 2. So 46.08 plus, that is minus 1. So 12540 upon 144 into 10 raised to minus 2. Any doubt in this, in calculation?
No, sir.
Okay, please do till this. Mostly in entrance, such lengthy calculation won't come, but in 11th standard exam they can ask. Any college started with physics, any chapter?
sir.
Which chapter they have started?
So optics and measurements and vectors.
Okay. And any date given for first exam?
No, sir.
Not yet?
Not yet.
Okay. Avan, what is your college time?
12 to 5.
12 to 5 o'clock. Okay. But regularly now it is started online, all the lectures?
Sir, yes.
And physical lecture, when they are starting, they have told anything?
Not told it.
Because I am hearing that in February, second week onwards, they may start with practicals.
Practicals also have started online.
So online practical?
Yeah. Biology.
Okay. Because for physics and chemistry, you have to be present in lab.
That not only bio.
Only bio they have started. After completion of this chapter, we'll start with optics. Current for you all also they started? Current Vora and Ane? Online lecture started?
So they are starting from today.
Okay. Today is the first lecture for you all. And then what is your timing?
12 to 3.
Okay.
Done, sir.
Just calculate and answer at home. Now I'm doing 2-3 MCQs. See, on common group, I have sent you one PDF sheet. Oxygen boils at minus 12085. First one, see MCQ. Oxygen boils at minus 185. Temperature is approximately how much in Fahrenheit? What is relation between Celsius and Fahrenheit? Celsius minus 0 upon 100 is Fahrenheit minus 32 upon 180. Clear? This connection?
Yes, sir.
Yes, sir.
This is any temperature. This is starting point. Any Fahrenheit temperature, starting point. 100 is difference between starting and ending. 180 means 212 and 32 ka difference. See, like if this is thermometer, its ice point is 0, boiling point is 100. So difference between them is 100. But if it is Fahrenheit wala scale, ice point 32, this is 212, difference is 180 that I have put here. Now it is boiling at minus 185. So C is minus 185 upon 100. F you have to calculate in Fahrenheit. Minus 32 upon 180. 20 into 5. 20 into 9. I can cancel this also by 5. 5 into 3 is 15. 5 into 15, remember 3. 735. So minus 37 into 9 equals to F minus 32. That is 9 into 7, 63. Carry 6. 9 3s are 27 and 6, 33 in minus equals to F minus 32. So minus 333 plus 32 is in Fahrenheit. This will become 3 minus 2, 1, 0. 3 minus 3, 0. Minus 301 Fahrenheit. So option B. Any doubt in the sum? Yes, any doubt in the sum?
No, sir.
No, sir.
Please copy.
Done, sir.
Then one last sum for today. The Fahrenheit and the Kelvin scale of temperature will give the same reading when?
Option C.
Option C.
Acha, we had done this earlier.
Sir.
Chalo, ठीक है. Option C. Others, please see how to do. Fahrenheit scale minus 32 upon 180 is Kelvin scale minus, you can take 273.15, no need to write, upon 100. So 20 into 9, 20 into 5. Let the temperature be X where it is becoming same, equal to X minus 273 upon 5. Now you can do after this. What option you are getting? C. Everybody can do now after this.
Yes.
Yes, sir.
Please do it full. Chalo, done. Don't get distracted because so many things have started now. College plus lectures and every teacher's test. So be careful, plan the things properly. Any guidance you require, call me separately.